Okay, we'll make a start now. Good afternoon, everyone, and yeah, welcome to our November installment of our webinars. We are the Circular Economy Powered Renewable Energy Center, and we are a Pan-African research institute with academics from across Sub-Saharan Africa and the UK. And what we're doing is simple. We're making sure that we can leverage the principles of the circular economy to advance Africa's energy transition. And we're doing that from a social science as well as an engineering perspective. So we're a highly interdisciplinary team. And in this webinar today, we are privileged to have Professor Juliana Battisti present to us. Juliana is a professor of economics of innovation at the Warwick Business School in the University of Warwick. She has a very rich CV. Some of her achievements include she's currently the co-lead for Warwick Sustainability Spotlight Research Initiative. She's a member of the National Statistical Advisory Group in the UK and is a former trustee of the Royal Statistical Society. She's been involved in several research projects, both from UKRI and the EU, European Commission. And so today she brings a wealth of expertise and experience in giving us a few insights into the topic of from innovation to impact, advancing the adoption of circular energy solutions. I won't want to say too much, but as you can see, Juliana is also on the leadership team of the center. She's deputy director leading everything regarding social sciences. So without saying much more, I will give the floor to Professor Battisti.
Oh, thank you very much, Muyiwa. So today, this webinar is about what we want to do very briefly, and then I thought to share with you what in my direct field, which is the economics of innovation, what we know about the diffusion of innovation, or what is the understanding about the diffusion of innovation. And I also hint at the management side and the different approaches to the uptake of innovations. So, as you know, if you're here, because probably you know this, that actually, if we look at the countries without electricity in the world now, in 2025, what is striking is that the continent without the least access to electricity, and is so strikingly peculiar in the world map, is Africa. The dark blue indicates areas where the electrification is 100%, while areas with a light color, the lighter is the color, the lower is the level of electrification. The lowest is 0, as you can see from the horizontal scale here, 0, 10, 20, 30%, 40%. That means that that's a percentage of total population in that region with access to electricity. So the lighter, the lower the connectivity for the population. Again, why it's such a priority for us is because globally, there are 730 million people that remain without electricity, remain in the dark. So that means that not only that there discontinuous access to electricity, but there are areas where there is no electricity at all. So this is what we try to address. And strikingly, 85% of this population without access to electricity is in sub-Saharan country. 85, well, if you look at Africa, it's not homogeneous. There are the majority of lack of access in the sub-Saharan countries. And in these figures, we omit not just us, but the International Energy Agency excludes South Africa because the connectivity is rather higher in South Africa. But still, what it is, again, something that is really noticeable, at that all this population without access to electricity, 85% are in sub-Saharan Africa. And within Africa, that means that this is about 43% of the population do not have continuous access or access at all to electricity. And that is quite a concern. And even worse are the access in rural areas, whereby only 84 those without electricity live in rural communities. And that is what moved us as a CEPREC to try to find a solution to this problem. Another piece of information, just to set the scene, I'm sure my colleagues in previous CEPREC webinar might have highlighted this, but it is quite important to reposition where we are starting from. So if we look at the whole population, on the right-hand side here, there is a graph. If we look at the proportion of population without access to electricity, we can see that the proportion has decreased. So the number of people without access has decreased from 2010 up to today. However, if we look closely at the composition, we can see that the majority of this decrease is attributable to developing Asia. A very small proportion in the rest of the world has been steadily stable around the lack of access, but the proportion is really limited. What is surprising is that in Africa, if we look at Africa or sub-Saharan Africa, we can see that from 2010 to 2025, the proportion, the access to electricity has remained almost unchanged. Some may argue that, well, there is an underlying factor below that. There is a growth of population keeps growing, and although the electrification progresses, when we look per capita in terms of proportion of population, then sometimes the advancement in the electrification is neutralized by the larger population. So perhaps we don't see so much change, the stability of Africa, but still, whatever is the reason, about 600 million people are without electricity. And that is where we're starting from. And a lot of countries are aware of this, and Africa is changing rapidly. As I said, they're trying to find solutions, and one of them is microgrids. Microgrids are solutions. They are local generator. They are very, very popular in Africa, and they're decentralized energy solutions. So microgrids could be attached to the grid or could be independent. And what is particularly useful for especially areas where the main grid, the national grid, can't reach, or they are, because it's too costly to reach, or they are scarcely populated area, then microgrid seems to be a solution. And a lot of funds, international funds, projects are now trying to favor the installation of this microgrid. Here we have three examples, three pictures, and they show you typical use. Well, one is the person on the top left is using the photovoltaic, the generator, to recharge his laptop. On the right-hand side, we have microgrid that is used for irrigation, to power irrigation in agriculture. At the bottom right, we have other modalities of use of microgrids. So the one here, for example, bottom left, you can see some photovoltaic, solar photovoltaic energy provider that provide energy for the household. So it's a solar home system, what is called. And if you notice, there are also many other solar PVs on other roofs, because this is an example of a development of these microgrids, which is community microgrids, where households become prosumers, users and producers of electricity, Together, they connect so that there is no waste of energy, so that when electricity is produced, it can be used by households that they need more, and use the excess of another household. And there are systems that are developed to manage these transactions and buying and selling electricity. But as you can see, they can be designed for small communities and managed locally. And this is ideal. We have to remember that Africa hasn't got a lot of resources. Governments are not rich. So it's not like talking about the setting up the infrastructure or that we went through perhaps in developed economies. So where we give for granted that telephone is everywhere, water, gas, access to Wi-Fi. Well, this was possible because government had resources to distribute, to maintain. That is what they do, this infrastructure. Africa not having a very low GDP, can't rely on taxation to generate income, to generate resources sufficient for them to be redistributed by government. So microgrid seems to be a good solution, and many think priority number one is to make sure everything access electricity. Priority two will be whether we should try to connect everything to the main national grids or not, but that is a secondary issue. And SEPREC, as SEPREC project, we try to focus on this microgrid. As you can see, microgrids can help apart from the domestic use, but can be used also for stimulating development and advancement, more sophisticated, more productive way of farming the land. Energy can lead also to industrialization, to the type of businesses. At the moment, electricity is rather discontinuous. Even microgrids are struggling to spread as quickly as we would wish, because if you speak to local people, they will tell you, well, the standards are not necessarily there. You know, sometimes the solar doesn't work very well, or perhaps the standard of electricity is discontinuous. When it breaks down, who repairs it? The upfront cost is very high. So there are a number of issues that, although we know that microgrids are important, that are slowing down in the extent of the uptake in many African countries. So what we are trying to do as a SEPREC, trying to find a way in which we produce microgrids that are relatively affordable, in an affordable way, in a sustainable way. And we are trying to think, designing a model that can favor both the user as well as the producer, or who has to look after and distribute the microgrids. So what is new about SEPREC? Well, sustainable microgrids already exist, as I showed you in the pictures, where they relies on the photovoltaic, they have a battery, the controller, the inverter, etc. And they're sustainable because they use sustainable resources, so that they use renewable resources. You might argue that some are still powered in part by diesel, but the majority are sustainable by definition. The added value of SEPREC is that we are thinking of repurposing existing materials, such as electrical vehicles, so that the microgrids become circular, sustainable microgrids. What is circularity? Sometimes we give for granted the concept of circularity. I put here the picture just to clarify that circularity now is the modus operandi of many companies, and again, as any innovation, has got its own difficulties. But what does it mean? That, well, the company produces the batteries. That is, in this case, if we take the example of batteries, they're incorporated into vehicles. At the end of the life of the vehicle, the battery can be recycled or can be repurposed. That is where circularity starts. One part of circularity, where you think of the second life. So you extract the battery, you repurpose, as we want to do, to fuel these microgrids. And when we won't be able to use the microgrids anymore, then the battery can be recycled and thrown away, or continue, we can extract the basic materials, which are really precious, everybody's after, and together with the natural material, the raw material, then we'll go back and we start being reused for new battery production. What we want to do then is to reuse the batteries because it's cheaper. So repurposing, it might not be cheaper in many countries where labor cost is high, but in many African countries where labor cost is lower, it is really a viable solution to repurpose the batteries and to reuse them to support the microgrid. So the microgrid becomes, as I said, circular, sustainable, cheaper, and more usable. What do we know now? We're talking about this lovely technological solution. But how do we make sure that they're used? Solar panels, microgrids are needed. There are many areas in Africa where they're not. So why does it take so long to be taken up, to be used? And then we are sure that even when we introduce the circularity principle, whereby the microgrid is going to be cheaper, there will be still delays in the uptake, in the diffusion. And that is what the social sciences in the project will try to address. We are trying to make sure that these viable technologies that our colleagues are producing in their labs around the 6 African nations we are working with, which are Namibia, Nigeria, South Africa, Sierra Leone, Rwanda, and Kenya, as well as researchers in the labs in the UK. Once we have these products and we know the cost, we know the efficiency, we know everything, how do we make sure that it's used? And the social sciences now are actively, we have a team of overall of 17 PhD students that are helping us to collect information, contact stakeholders, and trying to understand what is the best way to make it happen. If we take just a step back, the microgrid can be seen as an innovation and new technologies, and there are many examples we can learn from in the past of new technologies. Schumpeter was the father of innovation, told us many years ago in 1942, well, we need to tackle the issues of innovations in a very peculiar way, in a very specific way. We have the invention stage, is probably where we had the idea of the circular microgrids. Then there is the innovation stage where you design. That is what's happening now within the project. All our social scientists are working hard to define, to identify the solution. So innovation is when the idea becomes tangible and ready, down to the stage when it's ready to go out and to be used. And there is the diffusion. The diffusion is what happened when this technology leaves the labs. And diffusion, we have, as I said, we can learn from many examples. On the left-hand side, I've reported a spread of wind installed capacity as a percentage of installed capacity across various countries. And you can see what is interesting, sorry if it is very small, but on the horizontal axis, we have the years. So it goes from 1980 to 2005. On the vertical axis, the proportion, the percentage of installed capacity. And as you can see, some countries like Denmark are very advanced. Some countries like probably Mexico, Turkey, I presume also a lot of Southern European countries, the wind installed capacity is not so high. And it takes time. As you can see, this curve takes off at different point in time. That is when they first start introducing these new technologies into these countries, and it takes decades to diffuse. Very often we think innovation new technology is enough to invent them. It's not true. Electrical vehicles were invented in 1800. Unfortunately, still now we struggle to diffuse, to make electrical vehicles, to convert existing standard fossil fuel led vehicles with electrical vehicles. And this takes a lot of effort, a lot of government intervention. People have to change taste. Organizations need to change their production system or set it up, as Elon Musk did, new factories just producing the electrical vehicles, or like China is doing, and so on. And there are countries that are faster catching up, or our countries that are very slow. This pattern of adoption is not just across countries, but can be seen also within countries. This is actually a work that I did quite a long time ago on the uptake of technology by the manufacturing sector in the UK, in the United Kingdom, where I'm based. I look at numerically controlled machine, computerized numerically controlled machine, coated and carbide tool machine, microprocessors. And if you look at these technologies from 1995, when they started appearing, well, in particular NC and COT, coated and carbide tools machine, and later the uptake, the microprocessors and CNC appeared far later in the UK market in mid-70s. Still, after decades, after even 40 decades or 30 years, 40 or 30 years, only 80% of the eligible companies have used it. So we still, and again, we can look at the uptake of fridges, radio cars, electricity. This is within the US. Here instead is the share of population of using internet in macro region, where, of course, the leading country is North America, sub-Saharan country we see is, and for obvious reason, is here at the bottom of the graph. So what do we know about this model? Well, one striking characteristic of all the diffusion process, as I said, is the overall slowness and the rate of acceptance. And there are degree of variation depending on the technology, depending on the countries, depending on many institutional factors, whether a technology exists, and so on. So this was noticed by Rosenberg in 1976. So what do we know? What have we learned about why it is rational? It is rational to delay adoption. Yeah? If you think about ourselves, how quickly do you adopt the latest technology? How many of us have got a solar panel installed in their house? How many of us use electrical vehicles? How many of us have switched to the latest gadget? Sometimes we wait. Sometimes we're not the first adopters. And it could be the right things to do, but we might not do it for a number of reasons. And that is rational. So what we do, it's rational for when, for now. If our conditions change, anything changes externally, internal to our household, to us, our perception, feeling, and disposable income, we might make different decisions. But it is rational to delay adoption in many cases. And why? So what we want to know about these curves, and I keep it short here, is that what leads the speeds. So everybody, businesses, governments, once they decide to implement a policy, they want it to spread quickly, implement quickly. We go from 0 to 100%. These S-shaped curves are just cumulative distribution. So they're cumulative distribution of unimodal distribution for the statistician or statistical mind that are listening to this webinar. So they're just the cumulative of any unimodal distribution. So there is nothing special. Any phenomena will reach its peak, and then the number of users will slowly decrease over time to reach the maximum point. On the vertical axis is the number of potential users or adopters, and then that is how this curve works. Just to give you, those of you that are not familiar with this literature, just give you a very just go through different explanations, just to make you aware that a lot of people, when I look at these issues, the epidemic approach, which is a typical approach, say, oh, technology should spread like a disease. So that there is a population of organizations, or we're talking about other firms or households that are not using the technology, the microgrid. Why? Well, because they need to be infected. It's like a disease. So if you put a microgrid in a community, then the person that adopts it might bump into another one and talking and say, oh, I've got a microgrid, you should use it. So by talking and by use, by example, people reduce their uncertainty about the new technology and say, okay, it works for him, it can work for me, so I'll adopt it. So it's sort of word of mouth. This model, it says, it's just information acquisition. You will see if you add one technology that works and in a community, then will slowly spread by information. And this approach has been taken. So there are models that try to say whether the S-shape is logistic, the Gompertz. You don't want to know all this technical. We leave it to economists, econometricians. But what they're trying to do is trying to look at what is leading, so it's word of mouth. It's like with the likelihood to contract a disease in a population of healthy. The more people contract the disease, the more likely you are to contract it, because the more people are using the technology, the more relaxed you are about it, the more likely you are to hear about the technology, and then you will become an adopter and a user. And this literature is used a lot in marketing and in the stream of research. Others instead say, oh, not a second, it's not true that the more people use the technology, then the more likely everybody are to use the technology, because there might be what are called rank, stock, and order approaches. These are specific to businesses, but you can relate it to any other user. The rank approach say the likelihood to adopt are intrinsic to the units that need to adopt it. So if you're a business, it depends, an existing business, it depends on the size, whether you have lack of resources, whether you have the capability, the competencies, and that is what will make you likely to use it. So tell me who you are, and I'll tell you how likely you are to start producing or start using microgrids. The stock approach say, oh, no, well, the likelihood that a new business will adopt it or will produce it depends on how many are using it already. And this is negative, because in economics, there is the principle that if you're a monopolist, you can shave all the profits. So you can have a markup, you can charge slightly more than your cost. And if you're alone, you can share all the benefit. If there are new entry into the market, they will start sharing the markup with you. So in order to compete with them, you have to reduce your returns, your margin. So as the number of users increases or producer increases, the least likelihood you are to follow them, because the markup, the premium from entering the market reduces, becomes thinner and thinner. And the order approach say, well, yeah, that is true. Order approaches use game theoretical model to say, well, actually, it is worth if you're first, because if you're first, you can benefit, you can share all the benefit, the extra profit. Ideally, you become the first forever, like Apple, or if you are down in the order of adoption, if you try to start making smartphones now, you enter a market that is already highly competitive. So again, it's not true that the more people do it, there is an incentive for you to do it. Another theory, debating on what are the drivers, the marketing, say, oh, you need word of mouth, advertising. A lot of people don't know about this technology. You should really, government do a lot of dissemination, give leaflets, organize events, go to conferences, business conferences, or Rogers. If you Google diffusion of innovation, you find Rogers, which is, in my view, has got a number of weaknesses. But what he says is, well, you need to look at the society, the sociological approach, which is a good point that he makes. Actually, I don't agree with other points, but this is very good of Roger. You need to think internal and social condition, the degree of acceptance, the prejudice, the way in which people are doing things. For example, this applies to businesses as to households. Think about going back to your household and all of a sudden telling your household, we have to do things different. We have to do very different technology. We have to use hydrogen kettles. We have to. They will look at you and say, no. We are happy with the technology we have now, partly because inertia, partly because of uncertainty, partly because of the cost. So this sociological aspect, it's there. The degree of acceptance, it could be an obstacle. Or there is the evolutionary approach that says, well, if it doesn't diffuse, it's because sometimes technology is not always the best technology that dominates. It happened with vehicles. The best technology was probably with inside electrical vehicles, but we chose the petrol-driven vehicle, and look at where we are now. So dominance is not always the best technology. That is why they don't spread, or inferior technology spreads more than superior technologies. And then we have, lastly, the management approach. The management approach to the diffusion of innovation is rather interesting because, and we have students in this CEPREC that look also, we have many students look at different aspects, but the managerial mindset, whether, what you need to have, trying to understand, especially in the African countries we are trying to address, what is the way in which potential entrepreneurs work. Are short-minded, do make plan in the short term, in the long term, how they can manage this ambidexterity between doing things now and planning for the next 5 years. But in the management approach, what the management is concerned with strategy. So they say, okay, let's introduce this technology. So if we want to do it, we need to have a strategy. First of all, we need to think whether there is a use, and indeed there is a use, there is a demand. If there is a demand, there is an innovation. That is, where there is a need, there is an innovation. Definitely the demand is there. The second aspect that we look at, who is involved, can we do it, and can we capture the value? In particular, they would look at who is involved. Do we have the technical capabilities, the commercial capabilities, the financial capability, the organizational capability, the management strategic vision, and the business model that works? Or perhaps can we capture the value if we decide to produce, to start making or using most of these technologies, but mostly making the technology? Well, it depends on the external network capabilities, the supply chain, which is very, very important, and none of the models I've mentioned so far have mentioned. The industry structures, where competitive market, mature market or not. What's the degree of competition from China introduces these microgrids, or what is the degree of the availability of vehicles that we are gonna have? What about the technological change? Companies invest, and then what if things happen and they have to divest? So they make a lot of different considerations, and often use scorecards like this. This is a scorecard that a large Celesio, a very large conglomerate multinational used to, the criteria they used to use to assess whether to start launching new technologies. And this is rather interesting because, as you can see, the management approach is taking into account a broader view. It takes into account the capabilities, takes into account the internal and the external dimension. And that is, in a sense, where we are starting as CEPREC. We are Work Package 6, led by Emmanuel. He gave us his webinar was a few weeks ago. He explained how they're tackling the degree of acceptance by households and potential businesses. What is the use they would make of the grid? What are their needs? What is their attitude? disposable income, how much they're willing to pay, how receptive they are to an upfront cost of the microgrid, and they're running a survey across these 6 countries. And then there is another team that is looking at all the who is involved, can we do it? Who is involved, can we do it? And can we capture the value? What is the best business model is another area, and especially of the business model that's going to be addressed by a colleague, William Murithi, from Strathmore University in Kenya, and it's going to be the topic of the next talk. So what is important of what we have said so far, especially what the management literature has highlighted, is actually that it's not just about worry about the diffusion across users. It's not just looking at the households, what use they make of it. We also need to consider the producer. So who is gonna provide this technology? Is it gonna be supplied as I always say, as an IKEA pack, pre-packed, and you give it to the communities, or there will be a company that assembles these technologies? Is a company that will deliver the technology, and again, that is why there is the importance of understanding the type of business model they want to use. Are they going to use electricity as a service, which is quite important? Or is it gonna use it as pay as you go? Is who will retain the ownership of the microgrid? Is that the community? And then there will be technicians, local or remotely, or companies that provide the service of maintenance. One of the things of microgrids, and use it interchangeably. Their phasing is when things go wrong. It's not just the initial installation, but who looks after them. So if you're really interested in continuous long-term energy provision, we really need to think beyond. Another interesting aspect, and I'm about to finish here, is that is emerging in this study, is how much countries should make and how much countries should buy. And that is not obvious, because if we look at the microgrid on the right-hand side, there are quite a few questions. For example, the PVs, are they bought from third countries? Is this worth, and then this embraces more industrial strategies at country level, or perhaps it's worth starting making these technologies in Africa? What about the batteries? What about all the precious materials that Africa is very rich of? Why Africa is not thinking about making, so positioning itself at the very beginning of the circularity, not at the end when second-hand products are reaching Africa, but why they're not positioning themselves in making batteries? It is not easy. We're already speaking to a lot of local businesses in the Nigeria and many other countries. They tell us, well, actually, we went also to the UN General Assembly and we had the chance to meet to other stakeholders there. And it seems that standards and could be an issue. The setting standard could facilitate the startup of the businesses, the financial sources could facilitate the production, but at the same time, this is what is emerging is a broader picture that goes beyond the sustainable circular microgrid, which is, if we want to have microgrid, fine, we can't just stop at giving the microgrid to the community. We need to think about where the components of the microgrid are coming from, whether we need to develop the local expertise, ideally, in African countries to produce the local components and start and using the transition as a way to start launching the industrialization in the African countries. So that's a very ambitious task. that we have set ourselves with. And the first task we want is to really see this microgrid, circular microgrid, working and bringing energy and reducing the share of population without energy and electricity. And that is a very good point to start, but also we are willing to engage, a very courageous engaging conversation. What if instead we started retain ownership of all parts and started thinking of making them locally rather than buying them from overseas? What about FDIs, foreign direct investments, having companies to produce in Africa? That is where we are. Please stay synchronized with us, because the next, we are very ambitious as to where we want to lead our conversations. If you want to know about the business models that we're evaluating so far as the interface between the producer and the user, please join us for the next webinar. As I said, will be led by our colleague, William Moriti from Strathmore University in Kenya. And I'm open to questions if you have any.
Thank you very much, Juliana. Yeah, if you have questions, if you just raise your hand, I will unmute you. Any questions or comments? Okay, we have Akinola. 1 second. Okay, can you try unmuting yourself?
All right. Hello. Can you hear
Hello.
me? Okay, hi. Yeah, I'm Akinola Jayobe from MTC Coventry. I was just wondering because I'm very much interested in the circular economy program. I did present a paper recently in the IET conference in Italy around that area. So I was just wondering, how do you evaluate the components that you are focused on using for the mini and microgrid? Like if you were to use, let's say, the inverter from a Tesla car, do you have like tools that you use in evaluating them, or I don't know, because you just mentioned some scoring technique, or you are just focused on the business side, like the business model and things like that?
If I answer that question for you, Juliana, because that's
Yeah,
the technical question. So yes, we have a technical side of things where we are developing models to be able to characterize the life left in these components. So our colleagues from University of Warwick, led by Professor Latishe, just presented a paper at there's a conference. It was in Philadelphia last month.
ECC.
Yes, I think so. Yeah.
Yeah.
On a framework for doing that. So not just the electronic company. So we can look at it. I think if you look at our LinkedIn feed, you'll see a bit more details about that. But yes, there's a complex way, and we have some lab kits going in which we are using to test all these sort of things.
All right, thank you.
I mentioned although electrical EV batteries, but what they're looking at now with our colleagues, and as Muyiwa said, we're looking also at inverter converters, microgeneration system, electric motors as microgeneration. So we're trying to look at the various components. So just to clarify this, because I mentioned only the battery, EV battery. But yes, indeed, but we'll have to speak to our scientists.
No problem. I used to be a research fellow at the University of Warwick myself, so I know Professor Latisha and Jose very well. So yeah, I can always reach out to them. Yeah. All right, thanks.
Yeah, that's very good. I hope you enjoyed the conference in Italy.
Yeah,
as well.
yeah, it was good. Yeah. Thank you.
Okay.
Any other questions or comments? I'll ask one question, Juliana. So there are quite a lot of models out there and code. Do you, in terms of validation in a global South context, do you know if there's been loads of all that? Do you know if they apply, or do you think we should tread with caution, or I don't know? Do you understand what?
Yeah. These are models, you're right, are mostly developed for during the manufacturing of probably of Europe, and they go from the 70s even earlier onward. There are applications too, and that is what the interesting part to the African context. There are some studies, but not many, and the main reason is because the lack of data. There are even now, when we're trying to look at the overall uptake of microgrids or the electrical vehicles, you can imagine having the exact number of cars on the streets. The statistical offices are not all equal in collecting this information. Yeah, they have their own priorities, so they tend to privilege our area. So the lack of data has stopped a bit the application of this study. And that is why in this project, we have designed 2 large surveys to be carried out in 6 different contexts. As I said, South Africa, and Namibia, Nigeria, Kenya, Sierra Leone, Rwanda, asking what is the use, the needs, how they would be using, what is the context, what is the political setting. And on the other side, we're engaging with businesses and policymakers, organizing roundtables, just trying to contextualize the potential uptake and use, and how to facilitate it, how to remove the nodes and speed up technology adoption, which is rather sometimes it could be contested. So in innovation studies, we say you have to be careful to make sure that the innovation doesn't spread too fast. That is the paradox, because that will affect the businesses. If innovation spread too quickly, the margin they can make out of the sale of those is very low, and they might deter entry into the market. As I said, mobile phones, one thing, if you have got enough time to enter the market and start finding your way as a producer, if instead technology spread too fast, you reach immediately the economies of scale, and you might demotivate entrepreneurs to enter the market. So we're working on industrial strategy, on policies like rapidly reducing prices. They are good for the consumers, but they're not necessarily good for the producers. And if we want to make microgrids in Africa, we need to make, in any context, when we want to make spread an innovation, we need to make sure that the price is right, and then the product is right for the user, but also for the producer, to stimulate entrepreneurship in that area. And that is why we use this model to try to understand better. And of course, we are engaging with banks, with financial institutions. We are engaging with policymakers. So we are taking the ecosystem that Muhiwa, you have very cleverly designed, the triple helix, or the integrated approach, where there are university, businesses, and government in this, in making sure that technology are used, this technology is used, and economically sustainable. So it's not just sustainable for the environment, but it's be economically and financially sustainable for the user and the producer as well.
Okay. Thank you very much, Juliana. So, Iata, I'll come back to you. Can try unmuting yourself.
Perhaps
Iata,
it's,
can you unmute yourself? Probably. Okay, so we go to Akiana back and then we come back to you, hopefully.
Okay, just one question. So most of these African countries, they still don't have EVs well adopted, and they don't have any policy framework that supports it. Is that going to be a problem, or are you looking at just taking the second life components from like Europe and shipping it to Africa? How is the supply chain arrangement?
Again, okay, sorry, carry on.
Muya. No, you do it, Muya.
I was just going to say, yeah, that's a question that has been coming up right from when we were conceiving this project.
Okay.
But as you know, research is not for today.
Yeah.
It's for tomorrow. So generally, African governments are making policies that are moving towards electric vehicles. So that's one thing. There are already electric vehicles in Africa, not a lot, but there's a few here and there. So there's that one. But also, if you look at the current vehicles in Africa, most of them are secondhand from Europe. Okay, so what that means is that there's already a way that these vehicles get their ways to Africa. So when Europe and the West stop producing internal combustion engines and then these electric vehicles, most likely those vehicles will still find their ways there. Okay, so our project is not just looking at the technology or the business case, but there's also a strong policy angle. So like what sort of policies should be in place? And you just asked a question beforehand about how do you characterize? So how do we empower local institutions to be able to test so that we are sure that what is coming in is not crap? Do you understand? So we have different things like that. So that's part of what the project is looking at. So it's not just about today, but again, whether we like it or not, in a few years, electric vehicles will continue to increase in number. And so how do we manage that process? So Julian, I don't know if you had anything else to add.
Thank you.
It's a very good question, the one that was raised, and actually, and you're a very good answer. And that is why I was hinting we are exploring what is the best business model in the context of materials. A lot of materials are present in African countries. They go overseas, they are produced overseas, and then they come back as a second-hand life. So that is why there is, scope for thinking how much do we make and how much do we buy, and at which stage of the circularity we want to step in. There are some very courageous questions that need to be posed. The same applies to photovoltaic. If there is such a high demand of PV solar, how many are imported? How many are produced? And that is why, it's my personal opinion, I would attach to whatever we find a clear industrial strategy and proving the potential for growth and the potential for using this technology as a means to start even the local entrepreneurship, help. It will be wrong. The quality won't be there. I've seen it with many other countries like China. The quality hasn't been there for a very long time, but it's the step of development, encouraging also the making, having the local skills and the going through the manufacturing the level of development, not just buying and use it as service, but retaining some ownership. Soon, many countries will face, including China, that we rely so much upon, have been relying because of cheap material, cheap labor, labor costs will start increasing, and the products are not gonna be as viable as, which is a non-natural stage of development, because internal demand goes up, the country become richer, wages are higher, everything will start costing more soon. So we need other countries producing some of the technology, some of the material. Why not Africa starting the industrialization process through this, where the parts come from? And do we have enough? Do we make them or do we buy? That is another interesting question, again, for future strategy, long-term strategy, but strategy for growth, economic growth.
Thank you.
Thank you. Thank you very much. Iata, are you able to speak? Unmute? Probably not. But well, I think our time is fast spent. It's just 1 minute to the hour. So thank you very much, first and foremost, Professor Battisti, and thank you to you all for joining. In the chat, I've just put a link to our link tree, so you can catch up on, you can see our YouTube channel there and catch up on previous webinars and other things we're up to. Our LinkedIn, where we usually share updates on what we're up to. Yeah, just stay in touch. But thank you so much for joining, and we look forward to connecting with you in some way, shape, or form in the near future. Enjoy the rest of your week.
Bye-bye.
Well, thank you. Bye.
Bye.